Hello everyone, good morning. Thank you so much for being here with us today, and we are so happy to have you all. As a part of Bluebricks, I take a great pride in welcoming you all to this virtual event on cybersecurity AI series with facial biometric as a first topic. So we are going to organize this kind of events and series, especially on cybersecurity AI on every second Thursday. And coming to our company, we are Bluebricks. We are a niche cybersecurity product development company since 7 years, and till now we have executed 120 plus projects successfully. And these are our offices where we have our existence. We have our existence in Australia, Malaysia, India, and in India we have our office in Pune and New Delhi. And we are a team of 45 strong members who are working very hard to innovate and build the products. And these are the regions where our clients are based out of. We have our clients in America, Asia Pacific, like Middle East, Europe, and Africa. So what we are going to look into this session is what is facial biometric, and what is why it is important, how does it works. So just let me quickly give you a brief about what is facial biometric. So basically it is a process of identifying and verifying the identity of a person using its face, and basically it captures, analyzes, and compares patterns based on the person's facial details. In short, identification answers the question of who you are, and authentication answers the question of are you really the person who you say that you are. And without any let me quickly introduce our speakers of today, who is Mr. Vikram Sareen, who is the CEO and founder of Bluebricks. He is having a 21 plus years of experience in cybersecurity domain, and he have a patents under his name. And coming to our next speaker, who is Mr. Sandeep Dar. He's a AI and ML expert at Bluebricks. He's having an overall experience of 20 plus. He comes from IIT Kanpur. And let's start our session. Over to you, Mr. Vikram sir. Thank you so much.
Thank you so much, Hiran. It's always good to have Sandeep on the call. Every time I think in fact I get to learn something from him. So I think my job would be to quickly share, what are the use cases and a little bit about the problems that facial biometrics can help with. So what I'm going to do is that I'm going to share my screen and then straight away jump into the slides. Yeah. So okay, guys, can you see my screen?
Yes.
Yeah. Okay. Awesome.
Yes.
So we call it FBio, short for facial biometrics, and it's an on-prem or a cloud deployment. So whichever you would like to suit. So on-prem is good if in case your regulators are sensitive for you to share, data and shouldn't go outside, your network or your country's boundary. And essentially, it gives any web, mobile, web, or native applications, which could be for iOS, Android, or Huawei, with a much fast, reliable access. So it's something that can run on the phone or something which can be used as an API. So let's deep dive into it. So in essence, there are very typical problems that are happening right now that I think facial biometrics can solve. And as you could see over here, that there's a whole list of things from onboarding, asking too many questions, customer classification, because most of the time you don't know who the person is walking in. And then obviously strengthening credentials. So trying to move away or beef up from a single or a two-factor to multi-factor, and facial becomes, much more prominent over there. And lastly, obviously, getting into future readiness where, any digital applications will have a video call as a part of it, which is what we are doing now. But can we bring facial biometrics or voice biometrics inside that? So there are a lot of next generation problems that are out there. And I think facial does help you to solve those problems. So obviously you have, FIDO, which is basically enabling the native part, but in many use cases, FIDO is not available for other applications, or WebOS is not available for other applications. So our technology or our platform, helps you do that. So very quickly, I won't go into slides, but what you would see is that KYC or eKYC or VKYC, video KYC, is becoming very, very popular. Why? And all these 4 items which you see over here essentially lead to that. So what we are trying to do is that can we bring facial to help solve the problem of going paperless, but at the same time also, make sure that the person who's onboarded is a correct person. Then customer classification. This is one of the most critical, I would say use cases going forward, where you want people to not waste their time telling who they are. So if you're walking into a barista, or if you're walking into a mall, if you're walking into a bank, with something as simple as giving access to your face solves that problem. So it not just reduces, but it also makes things more efficient and helps things get cataloged. And in many places, employee attendance has actually moved away from smart cards to facial, and we have done a couple of projects in that. So that is one of the things which facial can solve very well. The next is strengthening of credentials. And now what you see over here is that what really happens, like if there's a malicious insider or a negligent insider, or a credential theft has happened. So in a sense, if you bring or move them away from just simple passwords, you're strengthening a lot of security. And somebody who's moving, who's active, who's alive, if they can be present on their desktop or on their mobile to authenticate themselves, suddenly it elevates the security a lot. So if I'm walking into an ATM, or if I'm walking into a building, that can also help me making sure it's the right person who's walking in. So it's more like a CCTV concept in the digital world, helping that. So strengthening credentials is one of the key use cases. Future readiness. I think most of us are at least 3 to 4 hours. We are on, Zoom, WebEx, Google Meet, Microsoft Teams. We are always on a call, and these calls are getting extended, to conduct businesses, from online polling, voting, to obviously customer onboarding and many other things. So I think anything going forward, in a digital world or cyber world, will demand you to have facial biometrics becoming part and parcel of identifying the user. Are they the real person who they are in the call, or are they the person who they claim to be? So imagine you are having a Zoom call with 10 people, but you have a facial engine in the backend, which is actually identifying who are these people using the face as well as the voice. So it solves a very, very interesting problem going forward. Next, one of the best use cases, I love is, let's say, for example, I'm a bank or I'm an insurance company. I have my mobile app, which is where I'm onboarding my customers. I also have my web app, which is where I'm onboarding my customers. But I'm not just stopping over here, but I'm also, having that same access where the people are walking into the branch or walk-ins or at the ATM. I'm also able to extend my facial biometrics over there, so that you can enjoy, the benefits of facial. So if you're walking into a branch, going to an ATM, or getting into a support video call, all these things can also use facial as a way of authenticating. And this is exactly what this slide depicts, where we have our SDK sitting over here, and the CCTV gives you the real-time feed and solves the problem of facial matching or searching, which I think Sandeep will talk about. So again, a very useful use case for how you can centralize face as a way of bringing more use cases, not just from onboarding or KYC point of view, but also using it later when it comes to authentication. Okay, just a quick slide gets asked so many times to us. How much time does it take to roll out? Not more than 2 or 3 months from POC to going live. That's the time you have to look into. Now, obviously, I very quickly want to cover the side of what is the what are the bad things that can happen in facial. So there are a few things that like any technology, there is always a boundary or a limit. So things like somebody showing a static photo, so that means it's a pad attack, a presentation attack, changing face over time, aging, or putting on some weight, like myself over here, or actually checking cross with the documents, but documents have a very small photo, and that photo gets a blur, or gets kind of used over time, so it becomes unclear. And then playing a video call, like using a deep fake, generating a video and then playing it, and then obviously doing a multiple wrong attempts into the system. So these are the things which can be attacked on facial. Not to worry, there's always a way around it. So you need to know what can go wrong, what are the boundaries, and you need to say how we can fix them. So let's quickly look at few of the use cases. Because of limited time, I can't go through everything. So static is something which is getting handled by pad attack. So over here, we again use AI, to help capture that, and we have active and passive liveliness. This solves that problem where we identify if the person is showing a photo or a video, and then match that. Second is document identification. So over here, we have a very interesting engine, which I think Sandeep will talk briefly about, is how we can use the photo which is on your ID document and match it with the face that you're giving, with a single photo, single shot, photo in that case. And then lastly, aging over time. So we have a very interesting module where we relearn, after every 3 or 6 months or after certain images, and that helps you to, evolve over time and help you to address the problem of aging, or facial changes that can happen over time. Now, very briefly, I'm going to jump into a portal, our portal, and I'll very quickly show you 1 or 2 examples of how facial, can work, and how it can add value, to your system. So this is our Ready APIs. It's a platform which offers low-level, APIs, cybersecurity APIs. And over here, I'm logging in. So we have a lot of APIs that you can enjoy from. And in that, we have the facial category over here. And then we also have certain others which are basically for active and passive liveliness. So over here, I'm coming back and I'm looking at facial search. So as I told you that if somebody walks in and I'm able to do, find out who this person is. So over here, it's me. So I'm clicking my photo. This could be a live feed, or this could be a user. So this will actually tell me if I am being registered, a single or multiple times over here. So over here, as you would see, that I am registered as multiple users. That means I have multiple accounts with the bank, or a company, or and which is where these are my IDs that are being used. Now, and you can see that the accuracy is 99.3% and above, the confidence level for this thing, and the response time was 3 seconds for searching hundreds of faces inside. In the similar way, you can also come and verify. So you come over here, you give the user ID. So I'm giving over here. I'm clicking myself again, and then so this one is very specific where you want to say, okay, hey, do I have the specific user? And against that, I want to verify the person. So you could see that for Vikram, 99.46% accuracy. It's a pure software, fast, and gets the job done. Now, this is where the SDK, which is what you see over here, you have server-side APIs which you can integrate, and we also have the client-side APIs which are under Sonic eKYC that can do the job for doing the facial capturing and everything. So now, if you want to build a system, which is, let's say, a chat, show your face, identify the user, push it to the person, to the RM, to the relationship manager. Now, this particular part can be done very easily by just calling a single API call. So you show the photo, and we can quickly tell you who this person is. Now, another use case would be that where you say, okay, hey, I'm opening an app, I'm showing a video like the way I was showing, I'm capturing the face, I'm showing the document ID, and then both get verified and done that. Again, it's a single API call, job gets done. So imagine that these 2 use cases which I'm showing you are so quick to do, so quick to execute. Now, what we'll do is that we'll, I think, dive a little bit deeper, with Sandeep's expertise, in next 3 to 5 minutes into the actually algorithms that are being used, which are pure software, proven algorithms, and taking it ahead. So Sandeep, it's all yours now. So you can go ahead.
Yeah, thank you, Vikram. So our facial biometric basically consists of 2 deep learning based models or algorithms. One is multitask cascaded convolutional neural network, MTCNN. It's a combination of 3 neural networks, VNet, RNet, and ONet. And also we have another model that is also being used in facial biometric, that is FaceNet model for face recognition or comparison of 2 faces. So multitask cascaded convolutional neural network, MTCNN model, basically detects face in a given image. As you can see in this photo here, so it detects the face in a given image and also returns the face bounding box. and it has about 95% accuracy. And for detecting face, we use 0.98 or above confidence level. Next slide, please. Yeah, second model that is used is FaceNet model of Google for face recognition or comparison of two faces. And it also uses deep convolutional neural network. And please note that the outputs from the first model, that is the MTCNN model, are sent to this model, FaceNet model, as inputs. So that means the bounding box detected by MTCNN model is sent to FaceNet model as input. And this is also a state-of-the-art model, FaceNet model. It has also above 90% accuracy. Even multiple photos can give you as high as 98% accuracy. And for the authentication of face, we use 0.85 confidence level. And even the self-learning is also done here. And it's also state-of-the-art model and very fast. Next slide, please.
So just to share, Sandeep, what you are saying is that it's not just the combination of a single algorithm, but it's two algorithms that are combined together to give such a high accuracy, and actually it works very fast. In less than a second, we are able to achieve such a good output. Am I right?
Yeah. Yes, correct.
Great.
Yes. So first step is the registration of your photo. So for the registration of face of a person, 3 photos are captured from webcam, or if existing images are available of the person, they can be also uploaded. And these images are sent to MTCNN model, which detects the faces in all the images and returns bounding boxes, face bounding boxes. These face bounding box data are sent to FaceNet model, and FaceNet model extracts high-level face features from these face images and creates face embeddings. Now, face embedding is a vector which basically represents the feature extracted from the face. And this face embedding is supposed to be unique for a person's face. And so, this since there are 3 face photos of the person, so we have 3 face embeddings created by the FaceNet model. And it takes the average of these 3 face embeddings, and that is registered with some specified user ID.
Yeah. So Sandeep, if I just take right now and I say Vikram, test, right? That's the ID which I give, and then I quickly come and click 3 photos.
Yes, 3
that
photos.
means that's all I need to do. Am I right? That's as simple as that. Yeah.
Photo 1, photo 2, photo 3, and then you have to click on submit request.
Yeah. Okay.
So on the background,
so this can be done from
model,
either web or mobile, or existing data source. Any way we can accept it, and then it works quite well. Yeah. Okay. Fantastic.
Yeah. Can you please go back to the slide?
Yeah.
So for registering, 3 photos are enough. And as you know, as I explained to you, that since there are 3 face photos of the person, so we have 3 face embeddings, and it takes the average of the 3 face embeddings, and that is registered with some specified user ID. Now, next step is the authentication or the verification of any new face image of the person, or just the image of the person. So for authentication or verification of any new face image or the image of the person, first that image is sent to MTCNN model, and MTCNN model detects the face in that given image, and it returns the face bounding box. Then this face bounding box is sent to FaceNet model, which extracts the high-level face features and creates face embeddings for this new face images of the person. Now, this new face embedding is compared with the registered face embedding of the person, and in output, we get a matching score, and depending on the matching score, it is decided whether this new face image of the person matches with the registered face of the person or not. Yeah.
So this is what would be your, the face embedding, and this is what gets matched. Am I right? In a layman term?
It is basically a vector. It is basically one-dimensional array, and it represents the feature extracted from the face, and it is supposed to be unique for a particular person's face.
Fantastic. Okay. Okay. And I think what we have done is we have already registered, the person, as you could see, guys, right? And then I think if you come over here, I could actually, put in, Vikram test, which is what I created, and I do the same process of me clicking.
You can
and
verify
then,
your new
submit.
face image.
Yeah. So this is an authentication, what I'm doing real time.
Authentication.
Correct? So as you could see, the system was actually gave me 99.47 accuracy as we are having this
above
demo,
99%.
99.47% accuracy based on that. So fantastic. I think this is much higher than 98. And I think the time taken was much lesser. Okay.
Yeah.
Sandeep, what would this particular feature be valued for, search?
Yeah, I'll explain. So for face search, or just the searching of a face, basically when any new image of a person comes in, so that image is first passed to MTCNN model. So MTCNN model detects the face in the given image, new image, and it returns the face bounding box. Then the face bounding box data is passed to FaceNet model, which extracts the high level face features from this new face image, and here's the face embedding. So you have got the new face embedding. Now this new face embedding is compared with all the face embeddings which are already registered in the face bank of different people. And if any match is found, and we will get matching score also for that. So depending on the matching score, it is decided if this new face image of any person, we don't know who that person is, whether it matches with any of the registered faces, face bank or not. Okay. And if match is found, we will get the user ID also, with whom it is matching.
With whom it has
the face of this unknown person is matching with whom.
So, okay. So over here, I think when I did that test again, the idea was that, if I'm putting my photo, so this will go and check, through MTCNN, then go to FaceNet, and then after that, have that vector and compare it with all the people that are there.
Yeah,
and you're right. So I think Vikram test has also started showing up here because I am one of the person who is also registered, right? And the face match was 99.
So you are registered with multiple user IDs.
Okay. Fantastic. Okay. So it's amazing to see that in action. Sandeep, I think when we talk about use cases, like if there are blacklisted people or rogue people, we can find their faces. If there are people who are, duplicate, like let's say if you want the system not to have duplicate people registering,
duplicate faces, duplicate
then
people.
you can, use this particular search feature. And then lastly, if you say that, hey, I want to segment my customers, right? So I think this also gets addressed by the search feature.
Exactly.
So it's different than authentication, because authentication, I think, is doing only for one person.
One particular person,
One particular person. But this one is going and searching for everybody.
Yeah, in the face bank, all the registered faces or registered people in the face. It will go on searching and then it will look for
Pradeep, can you please explain the last one, which is mostly the base of eKYC, is that photo ID versus, your selfie. So let's say I click a selfie, I click a photo ID. So how would that work, in terms of technology?
Yeah, I will just explain. So can you please go back to the slide?
Yeah,
last one. So we have another module called single shot face versus photo ID match. So where basically the face image of a person in a given image, face of a person in a given image is compared against the face in his or her photo ID, any of the photo IDs, in fact. Okay. And if any match is found, so we will get the matching score also, like how much that face of a person in a given image is matching with his or her photo ID plus one photo ID plus. So it will be very useful for the KYC or ID verification, identity verification.
Yeah, fantastic. And I think you're right. These are just one of the 4 things that facial can do. But again, I think there is so much more use cases that can be covered through this, right? So I think quickly cover this slide. If you really look at it, so what we have is that the way we have made the solution. One side is you have Fido, which is basically using the phone's biometrics. But in many other use cases, you want to have your own facial or voice biometrics or handwritten. So facial being one of the prominent ones. So we have the web and mobile SDK that's available. Then it obviously adds to multi-factor, so you can use it as an extra factor, over your desktop, over your over your physical access doors. And as you could see that it actually gives you ability to do things real time, and then also the system can actually manage many more things. So I think lastly, if you look at facial, it would reduce cost, frustration. It can be put into any application, and also helps you to become future ready and going forward. And lastly, which I love, is that happy customers, right? Which is most important, is that we have happy customers, and which can help you to grow your business. So I think with that, I would pass it back to Hiran. Hiran, if there are any questions which are for me, or I think more than me, for Sandeep, can you please pop it in?
Yes, sir. So actually, I have a question. Like you said that once the person registered, there will be a accuracy. What if the person next time have a beard, or have had a hat, or some wear some like, what do we say, specs like me? So what will happen? Will the accuracy will be same, or will that be different, or will that give a different result?
Yeah. Okay. So as long as person's face is clearly visible, for example, I'm wearing a specs. Okay. And I have, tested our face biometric model several times with specs. I wear specs all the time. So face is not a problem at all. Okay. So it doesn't affect the accuracy at all. And you can wear on hat also. As long as your face is not covered, it is clearly visible, hat won't have any effect. So it won't affect the accuracy, definitely. As long as his face is clearly visible, there is good background light. In fact, I will tell you what our facial biometric works also well, even if there is moderate background light. Low to moderate background, I have seen it many times, but it is advisable to have good background light.
Yeah. Even if I think, Hiran, the answer to your question is that if you look at this photo, there are two people who actually have specs, over here. And is still able to pick them up. So I think Sandeep is right that it gives you a good high accuracy.
Yeah, even beard don't have sorry to interrupt. Even beard don't have also any effect, because as long as person's face is clearly visible, and if that person carries beard all the time, so I don't think it will have any effect on the accuracy or results.
Okay. Any other questions, Hiran?
Like, does the accuracy level, or does the verification and identity level, that thing will get changed based on the light or the camera resolution? Like, if I once I register with a good quality camera, and next I have logged in with a normal kind of thing, will that change?
Yeah, I think Sandeep, that's a good question. That will the quality of image change the result? Am I right, Hiran? That's what you are. That's what is being asked, right? That will the quality of image, will change, the result?
Yeah. So as I told you, there should be good background light. Even if sometimes it works with a moderate background light, as I've seen. And in my case, even the webcam camera is of very poor quality, but with that also I always get 99% accuracy, and it doesn't really affect. So it works really well. And but it is advisable to have good background light and good resolution of your camera. But even in my case, the webcam quality is too bad, but with that also it works quite well. So I think definitely with the mobile smartphone, it will be much better, actually, the image quality.
I think just to highlight, many other, I think suppliers of facial biometrics, they actually say that we do not support webcam. And I think we are one of the few companies who actually say that, our system or module, as Sandeep rightly said, that it does work with webcams also. So that actually gives us, much powerful. And even, whenever you are seeing me, doing my registration, this is actually through webcam. So it's very, very powerful, in terms of how we have, used the algorithms and made it work, to its best, to give the best value, to the potential, customers or the applications that will use it. Yeah. I think, Hiran, I'm not sure how much time do we have, but are we all good? I think anybody who wants to check it out in this particular call, you can go to readyapis .com and you can try it out for free. These APIs are for free to use. For your personal interest and gain. You can come and open a free account. We give you free credits. And then you can come in and then do that. So go ahead, try it out at readyapis.com. And otherwise, you can obviously send us an email, right, Hiran?
Yes,
and
yes.
then we can understand your use case and work with you to solve that. Yeah. But special thanks to Sandeep, for explaining, how our facial biometric works. And it's not just for the web, but it's also for mobile. So we have made it mobile friendly. So you have the SDK that can sit on the mobile and do the same job offline. So if you're in a remote place, if you don't have internet, it can still work. Am I right, Sandeep? Is the right statement to make?
Yeah.
Yeah.
It is available
Using
offline
AI on the phone. Yeah.
Yeah.
Okay. Awesome. Hiran, back to you. I'm stopped sharing my screen, but thank you so much. Yeah. Great session.
Thank you so much, everyone, for participating here and for listening to us. And if you have any questions, I'll copy my email ID in the comment box. You can email me at any queries, any questions. If you have any questions that is not answered, or if you have any doubts you want to ask, you can mail me, or you can just comment it. We will be get back to
or
you
just
for
send us a
sure.
message on LinkedIn Live. Yeah.
Yes.